Next we'll be talking about the sustainable utilities at the facility. One thing we need to consider when looking at these sustainable utilities is that it's much cheaper to save a watt of energy than it is to produce a watt of energy. So what we're going to do is use all Energy Star appliances, as well as use lots of insulation and Energy Star appliance building materials. We're also going to take advantage of the climate in Ormond Beach. It's seasonally warm and also receives a large amount of sunlight throughout the year. According to the U.S. Department of Energy, the three main energy-consuming appliances in the home are space heating and cooling, water heating, and lighting. Those will be the things we're focusing on. Before we can do anything, we need to estimate the energy consumption of our center. It hasn't been built yet, so to estimate the energy consumption, we took all the appliances that we predicted will be in the office, took their wattage and how long they'd be on. For our center, we concluded that we'll be using about 27.2 kilowatts per day, which comes out to be about 826 kilowatts per month. We'll be using a solar electric system to power our facility. The way solar electric system works is photovoltaic panels collect sunlight and transfer the sun's photons into direct current electricity. From there, the direct current electricity is transferred to an inverter, where it's converted to alternating current electricity, and then it goes to the switchboard and then into the learning center. We'll be using SunPower's 320 watt E19 series panel. It's a high efficiency panel that uses monocrystalline silicon. We'll be using 20 panels of these and set it up in the 2x10 array right here. This array will be able to produce 6.4 kilowatts per hour, and it should be enough to supply our learning center with all the energy that we need. Next we'll be talking about the solar water heating system. We're going to be using an 80-40 direct system. The way this works is water is pumped from our water heater to a flat plate collector. The water enters the top of the flat plate collector, goes down long risers, and collects heat from the flat plate collector. It is then left from the flat plate collector and pumped back to the water heater. Leaving the flat plate collector, it can reach anywhere between 120 to 160 degrees Fahrenheit. All this will be controlled by a differential controller that will calculate the temperatures at the water heater and at the flat plate. If the desired temperature of the water heater falls below a specific temperature, it will kick on the pump and then circulate the water throughout the system. There will also be a backup heating element in it in case there's any failure with the system and hot water is not getting into the water heater. This will be the location of our solar modules. They're away from the building because of a couple reasons. Our client desired that our building be in nature, so we wanted to surround it with trees. And if we had the solar modules on the roof, they could be shaded by the trees and lose some of their efficiency. Another reason we decided to put them out here next to the retention pond is because we want awareness with the community around it. You know, we really want to promote you being energy efficient and using solar technology. So having it out there in the center will show the community that the learning center is eco-friendly. Next, we'll be talking about the geothermal heat pump system. This is what will be used to heat and cool our facility. As you remember, the majority of our energy consumed is heating and cooling the building. What this does is a vapor compression cycle that transfers heat from the ground to the building and vice versa. Using GeoDesigner, a computer graphic model, we determined that our center will need about 60,000 BTUs to cool it off. So that's about a 5-ton system. We decided to go with the Legend Series vertical 5-ton system. It has the ratings of EER about 16.6 BTUs per watt, and also can produce about 60,900 BTUs of cooling power. Conversely, the coefficient of performance is about 3.3 watts per watt, and it can produce about 47,000 BTUs of heat capacity. This will be the loop layout from our heat pump. The heat pump will transfer through heating fluid to these U-shaped loops in the ground. Each loop will be about 310 feet deep, and there will be 4 loops throughout the system. The loop system will be 2,500 feet of nylon tubing, and will be in an area about 1,200 feet southeast of the facility.
As Seth mentioned earlier, we wanted to focus on lighting as one of our sustainable utilities as well. And one way we're going to do that is we're going to try and use the majority of the lighting as the solar lighting, and then the natural lighting that's going to come in through the windows that are located facing the lake, and also the windows that are higher up into the structure, where we're going to place 6 by 3 foot wide light shelves that help reflect, because the inside is going to be painted light color, so it's going to help reflect the light throughout the building. In addition to that, We're going to also have some LED lights. That's the model we're going to have up there. They're going to be have 5 kilowatt bulbs, and they're going to be used because of their narrow band spectrum. So they're going to be used like in the prep area, in this office area, and small exhibit areas. And they use less energy, and they create less heat, which makes them one of the most efficient lights out there. We're also going to use fluorescent lights. These are going to be used like in our display room, which are larger areas that we need more ample light. And fluorescent lights actually produce 20 to 40% less, or use 20 to 40% less electricity than most lights, like the incandescent lights that we use every day. So, and here you can see the comparison of watts and the cost. And, generally, the LED and the fluorescent lights are more expensive, but if you look at the final totals, they're actually more cost-effective and energy-effective compared to normal incandescent lights.
Another thing the Department of Leisure Services wanted to know were specific rebates and incentives for these utilities. There's tons of rebates out there. And first, let's start with the water heater rebate offered by the Florida Power and Light Utility Company. They are offering $30 for every 1,000 BTUs your system produces. Our system has a possibility of producing 1,500 BTUs per feet square per day. Since we have about 40 square feet, it comes out to about 60,000 BTUs, netting a savings of about $1,700. Initial cost of our system is about $4,700, so we'll have a savings of about 38%. As well, they offer a solar electric system rebate. They offer it $2 per DC watt produced by our system. Our system can produce about 6,400 watts, so we get a savings of about $13,000. We have an initial cost of $35,000. We have a savings of 36%. As well, we use PV Watts 2.0, which is another computer modeling program for solar electric systems. This, once we typed in our specifications for our system, it analyzed that we could save about $1,100 per year in savings using solar electric systems. So this system will be able to pay off itself in about 19 years. Some other rebates that we have are the energy efficiency rebates. They have someone come out and check all the lighting, insulation, and other specifications you see here throughout our building, and we'll offer you a rebate through that. As well as there's a solar sales tax. If you have a specific form, you will not be charged any sales tax on equipment used, such as water heaters, flat plate collectors, and other things used in solar electric systems.
Now, besides performing a utility cost analysis, we also did a construction cost estimate using the cost books in line of RSM's CostWorks. It amounted to a total of about $105,000, and this is for the construction of the building, not counting the utilities, and the budget that we were given was for the entire structure and the utilities as well. Now, in completing our design, we still need to narrow down some details on the actual connection information. We have also been discussing a design of an outside extension in order to accommodate the equipment for the sustainable utilities, such as the geothermal heat pump. And we need to finalize some installation details on the companies that we're going to use to install the utilities. As far as the lessons learned, we learned early on that this was a very broad project, and we needed to narrow it down and focus on some main elements. Also, we learned that research has been key for every step of our process, especially since we began the concept out of scratch.